We're starting this lesson today with solving quadratic equations, but before we actually get into the solving quadratic equations, I'm going to get you to warm up with some questions here. The first one is just solving some simple linear equations, and then the second one is getting the values of the variables that will make the equation true. So I want you to think about those things. You should be able to do number one without too much difficulty. Number two, you might have to think a little bit about what it is that we're doing, especially for parts B and C. And then number three is just a review of determining the x-intercepts. So try those questions, put this on pause, try them out, and then you can check your work after. Okay, if you've done your work here, we know that with a linear equation, we need to rearrange it to get the x by itself. So we want to have x equals a number. So if you haven't done that, that's what you should do. And I'm going to go ahead and solve these, and then we'll quickly go through them. All right, for the first question, part A, you should have gotten that x equals -3 by subtracting 5 from both sides first and then dividing both sides by 3. For part B, you would have subtracted 2x first from both sides and then added 7 to both sides and then divided both sides by 6 to get x equals 1/2. Part C, you need to expand first, multiply the 3 through the bracket, multiply the 2 through the bracket, and then you get your variables on the same side. I subtracted 2x from both sides first. And then after that, I added 15 to both sides and I got x equals 23. So hopefully we agree with our answers there. For question number 2, what I have is 4 times a variable equals 0. To get the variable by itself, I could divide both sides by 4, and 0 divided by 4 is still 0, so x equals 0. But if you think about that, it says 4 times some number, so 4 times x, 4 times some number has to give you an answer of 0. Well, the only way you can get an answer of 0 when you're multiplying two things together is if one of those things is a 0. So that makes sense that 4 times 0 equals 0. And I'm going to use that property on the second example. Here we have x times y, so some number times another number equals 0. So if we use that same idea, the only way that this can equal 0 is if, and I didn't mean to use my highlighter, let's try that again, if our x value equals 0, so it's only going to equal 0 if x equals 0, or if y is equal to 0, or both. Okay, so if x equals 0, we would have 0 times, so 0 would go here, times some number. 0 times anything equals 0. Or if my y were to equal 0, I would have some number for x times a 0. That would equal 0 as well. So there's two possible things that can make that equation true. Either x equals 0 or y equals 0. So the same thing can happen with part C. If I have x times this bracket equals 0, either my x is equal to a 0, and if it were, I would have 0 times -1, because when I put a 0 in here for x, that bracket turns out to be -1. So 0 times -1 would equal 0. Or the other possibility is that x take away 1 is equal to 0, is the 0 values, which means that x would have to equal +1. And I just get that by adding 1 to both sides of that equation. So if x was equal to +1, what we have is +1 take away 1 inside that bracket, which makes that 0. And then 0 times, if x was 1, it would be 0 times 1, which would give us 0 again. All right, so that's an important piece of information there that we need. Now, example number 3, determine the x-intercepts. Now, we talked about this in our last unit. We know that if we have an x by itself, that really could be written as x take away 0, which means one of the x-intercepts is at 0. The other bracket was x take away 3, which means our second x-intercept is at +3. And if you don't believe me, you can always put that into Desmos and just do a double check with that. We talked about the zeros being switching the signs. Now, to take that a step further, if I were to find the x-intercepts, for any x-intercept, I know that y equals 0. So really what I'm doing is taking this y value and replacing it with 0. And I get 0 equals x times x take away 3. Now that really is like an equation that I had in the previous example. What that means then is that either this x is a 0, so x equals 0, or it means that x take away 3 equals 0, which then if I add 3 to both sides, we get x equals 3. And that corresponds to what we talked about in terms of x-intercepts. We talked about switching the signs when it's attached to the x. This is why we switch the signs. That's really the math behind it, what's happening there. So if I use that same premise on this next example, for my x-intercepts, I'm really letting y equal 0. So I have this little equation of 0 equals 2 times x take away 3 times x plus 4. So the only way that that product equals 0 is if x take away 3 equals 0. Whoops, that looks like an equal sign. Let me get rid of that. X take away 3 equals 0, which then means x is equal to 3 when I add 3 to both sides. Or we have x plus 4 equaling 0, which if I subtract 4 from both sides, we get x is equal to negative 4. So again, there's where we're switching our signs to find our x-intercepts. Now some students will say, well, what about this 2 here, Mrs. Logan? What's going on with that 2? Well, 2 is just a number. 2 is just 2. It will never equal 0. So it has no bearing on the x-intercepts in terms of where they are. That's just your stretch factor. That just makes your parabola skinnier or wider, or if it would be negative, it would be turning it upside down. So don't worry about the constants in front. It's just the variable pieces that we need to help us find x-intercepts or to solve our quadratic equations. So moving along here, solving quadratic equations by factoring. And this, I believe, should have an S right there. To find the zeros of a quadratic function or to solve a quadratic equation, one of the factors must equal 0. It's the only way that you're going to get an answer of 0. For example, if we had x times y, something times something else, then either x equals 0 or y equals 0. So we're setting up our little mini equations. I'm going to move back up to the top, example B above. If I look at example B above, this is like that piece of x, so either my x minus 3 equals 0, make that undone, x minus 3 equals 0, or x plus 4 equals 0. That's like the y piece. So it's the same as finding the x-intercepts of the related quadratic function, since the value of y at the x-intercepts is 0. So that's what we were just doing above. To find your x-intercepts, we're really letting y equal 0. Let's try and pull a pen out here. So I get y is equal to 0. So 0 equals, when I want to find my x-intercepts, I'm letting y equal 0. So I have 0 equals x take away 3 times x take away 5. And the only way the product of this times this will equal 0 is if either thing is 0 itself. So I make little mini equations, and we're really solving those little mini equations. Okay, or you just switch the signs, because that's what we were doing before with these simple ones. We will get into more complicated ones in a moment or two.